This video we're going to be going over what is called elasticity. Some of you have heard of it before in other classes. Others may hear about it in future classes. We're going to be focusing on elasticity, and we're in order to discuss elasticity, we need to remind ourselves of demand. Demand is the relationship between price and quantity, and we're going to be using little p for price and little q for quantity. Now, in previous sections, we have had p as a function of q. So we put in our quantity and we get out the price we should sell it at. But more intuitively, and maybe you're more familiar with, Q is a function of price, where we put in the price that we want to sell something, and we get out the quantity we expect to be sold. We get the quantity that the market demands at that particular price. So, like I said, this section is what we are going to be using. The Q is the output, where P is the price. So the formal definition of elasticity involves the absolute value of P over Q times dQ dP. Now, some books take out the absolute value, so make sure that you know whether or not your situation is the absolute value. Usually, for most markets, for most products, without the absolute value, you would have a negative number, because the relationship between P and Q is usually a negative relationship. The higher the price, the less quantity you expect to sell. So you expect Q to have a decreasing negative relationship, so that we would expect Q prime to be negative. And that's why a lot of places use the absolute values. Remember, I didn't mention this, but this is the same as dQ dP. So this is P over Q times Q prime. And then take the absolute value. That is the formula for elasticity. Now, many times we don't have this value, but we can approximate it with thinking about dQ and dP as actually infinitesimal measurements in change. And if you think of the difference quotients that we were looking at way back when in Chapter 2, over tinier and tinier time intervals, if you will, we would calculate the change in distance over the change in time. So with that, we get a similar formula that we approximate dQ by delta Q, which is the actual change in quantity, and we approximate dP with delta P. And if you were to do some algebra on this fraction, you would get something that looked similar to this with deltas instead of D's. But we have seen delta Q over Q before. Delta Q over Q, especially if you write it, this is seen as our relative or percent change in quantity over our percent change in price. So if we know we expect a certain percent change in quantity when we change, when we have a sale, for instance, in our price, then we can estimate the elasticity. Or if those are the data points that we have, when we increased tuition by 3%, we changed the enrollments by how many? So we also use this equation for approximating to approximate instead the percent change in quantity. So if we predict our change in demand by using, if we know our elasticity coefficient or number, again, without the absolute values, we expect the actual a number inside those absolute values to be negative. So in those situations, which are our usual situations, as opposed to, for instance, luxury items, where the higher the price, people think, oh, it must be better. So they actually sell more. So in the usual cases, if we change our price by a certain percent and we know our elasticity, we can predict our change in demand. So for these problems, we have to make sure, is our change in price positive or negative? So if we are decreasing our price, so if we're having a sale, this would be negative, making the whole thing positive, and we expect our quantity to increase. And the question is that sale going to contribute to this being so much more that we actually have the sale? So that's why we talk about volume pricing or sales. Some things go on sale all the time, and it's because of this, and also the idea that people are getting something on sale when really that is the real price. But we won't get into that. Likewise, if we increase our price, so this would be positive, so the whole thing would be negative, we expect our quantity to go down. But is the increase in price offsetting the quantity that we sell in such a way that our revenue still goes up? Is it still worth it to increase our price? So that's where the elasticity can come in to help us predict that. Some terminology. If the elasticity is greater than 1, we call the demand to be elastic. If it's less than 1, we consider it to be inelastic. And then we have equal 1. This is a lot less common, but we do have a term that's lesser known that's called unit elastic. Elastic demand, we have a greater than 1. The quantity sold is very sensitive to the change in price, or vice versa. And if it's inelastic, then the quantity sold isn't changed. And we're going to see these in subsequent examples. So our next example, we're going to be seeing tomatoes are elastic and eggs are inelastic. The sale price in tomatoes really contributes to a much bigger change in quantity, while the eggs not so much. People aren't paying attention to the price of eggs, they just want to buy them. Thing to keep in mind, different products have different elasticities. The same product might change its elasticity depending on where you are in the price point. Changing, price of a burger by 50 cents might not change a whole lot. People might not pay attention to much if it's a gourmet burger, but if it's a discount fast food burger, people will notice that change in price a lot more. So at different price points, you might have different elasticities, or a product, we might compare elasticities in products, and that's what we're going to be doing in the next several examples.